Have you ever seen those amazing 3D images that seem to float in midair or pop out of a flat surface? Those magical pictures are called holograms, and they're all around us, from credit cards to museum displays. Today we're going to discover the incredible science behind how holograms trick our eyes into seeing three-dimensional images that aren't really there. Get ready to learn about one of the coolest optical illusions in the world. Unlike regular photographs that only show us a flat picture, holograms capture and replay light in a very special way. When you look at a hologram, your eyes see different angles and depths just like looking at a real object. The amazing thing is that you don't need any special glasses or equipment. The hologram creates this 3D effect all by itself. You can even move your head around and see different parts of the image, just like you would with a real three-dimensional object sitting in front of you. Light travels in waves, kind of like ripples on a pond when you throw a stone in the water. Regular cameras only capture how bright or dim the light is, but holograms do something much more clever. They record both the brightness and the direction that light waves are traveling from every single point on an object. This means the hologram stores information about light coming from the top, bottom, sides, and everywhere in between, creating a complete light map. Creating a hologram requires a very special type of light called laser light, which is much more organized than regular light. Scientists split this laser beam into two parts. One beam bounces off the object being photographed, while the other beam goes straight to a special recording plate. When these two beams meet at the recording plate, they create an invisible pattern that gets permanently stored. This pattern contains all the secret information needed to recreate the 3D image later. The recording plate is covered with millions of tiny bumps and valleys that are far too small for your eyes to see. These microscopic patterns are created when the two laser beams interfere with each other, kind of like when two sets of water ripples crash together. Each tiny bump and valley stores information about the light that hit that exact spot. When you shine light on this plate later, these microscopic patterns redirect the light to recreate the original 3D image. Your brain is constantly trying to figure out how far away things are by looking at clues from both of your eyes. Each eye sees a slightly different view, and your brain combines these views to create depth perception. Holograms are so clever that they send different light information to each of your eyes, just like a real object would. This tricks your brain into thinking there's actually a three-dimensional object floating in space, even though it's really just organized light patterns. The most common type of hologram you'll see is called a rainbow hologram, which shows different colors when you tilt it back and forth. These special holograms work with regular white light instead of lasers, which makes them perfect for security features on credit cards and driver's licenses. You've probably seen them on sports trading cards, stickers, and even some product packaging. They're designed to be hard to copy, which helps prevent counterfeiting and fraud. Scientists and engineers are working on incredible new uses for hologram technology that will change our world. Doctors might soon use holograms to see inside patients' bodies in 3 dimensions, helping them perform better surgeries. Entertainment companies are developing holographic displays that could let you watch movies or play games with characters that appear to be standing right in your room. Some researchers are even working on holographic phones that would let you have conversations with 3D images of your friends and family. Now I'd love to hear from you. What's the coolest hologram you've ever seen in real life? Was it on a credit card, a trading card, at a museum, or somewhere else? Tell me about your hologram experience in the comments.